Hi everybody, in this video today we're going to be talking about how to write equations from context. So first of all, this is lesson 6.6, so you might want to add that to your paper. Also, I have some other things to write down here. I'm going to talk about that because for each of these situations we're going to look at whether it should be slope-intercept form or standard form equation. And so you need to know what to look for. With a slope-intercept form, you're going to look for something that says per and a starting point. Like you started with 5 and you added 3 more per hour. Whereas a standard form equation is going to have 2 types that equal up to a total. So for instance, you went to the grocery store and you bought apples and oranges and they added up to $25 altogether. Then after we decide which type, we're going to go ahead and write that equation. Part C, then we're going to make a table of values and we're going to make a rough sketch. And by rough sketch, it does not have to have everything in it. We'll just have a few key pieces in our graph, not a lot. All right, so to start with number 1, bread costs $3 per loaf and cheese costs $4 per pound. Matt has $24 to spend. So we have to decide which form is it. I think if you think about what I just said about how the type A plus type B is equal to the total, that's kind of what's going on here. We have bread, we have cheese, we have a total cost. So this is going to be standard form, AX plus BY equals C. And what we're going to do is $3 per loaf of bread and $4 per per pound of cheese is equal to $24. Now we didn't define our variables, but we should go over here at least on our graph. Our Y, look, our bread was the X and the cheese was the Y. So over here, let's put bread on this axis, and we'll put cheese on the Y-axis. Okay, how do we graph these? Well, when we were studying standard form equations, we talked about how you would plug in a 0 and find the other term, or you would plug in a 0 here and find the other one. So if you plug in a 0 for X, you're finding the Y-intercept. If you're plugging a 0 for Y, you're finding the X-intercept. And this is when we use that concept of the cover-up method. So we can do that here. If we cover up the X, then we get 24 and we divide by 4 and that gives us 6. So we could divide by 4 here, divide by 4 here, and that's going to give us Y equals 6. So I'm going to put 6 over here. All right, I'm going to erase this. You don't have to erase yours, but I need to erase mine because I'm out of space. So now if we cover up the Y, now we're going to divide by 3. So now we divide by 3 on both sides and we get X equals 8. So that's here, X equals 8. All right, our table of values actually asks for one more point. I don't think we really need another point, but if we have to have one, I suppose we could put one in. Over on the X column, we have a 0 and an 8. Maybe we could plug in a 4 and see what we get if we plug in a 4. So let's say we plug in a 4. Well, what do we do then? What we do is we plug that into the equation. So I'll show you over here. I'm going to take 3 times 4 plus 4y is equal to 24. And now I'm going to solve this. So that's 12. So I need to subtract that 12. So I have 4y is equal to 12, and I'll divide by 4, and I get y equals 3. So I'm going to take that 3 and put it in my table. I don't think we really had to have a third point, but that way we've got it. Okay, now when we go to our graph, when we put our sketch on our graph, we need an intercept at 0, 6. I'll just put that up here. And then one at 8, 0. So maybe that goes over here. And now we can connect those lines. And if we had graph paper, we could also do 4, 3, but that's going to be difficult to do just on this sketch. Remember, this was supposed to be a rough sketch, so it does not have to be perfect. It's just a rough sketch. So our line is going to look something like this. Okay, there's a little bit of a typo here because it says how many loaves of bread can he buy if he doesn't buy any cheese? The typo I'm talking about is the plural of loaf is loaves. Not that that's not important, but that's loaves. So how many can he buy if he doesn't buy any cheese? We actually answered that question in our table just a second ago. Because remember, I'm going to come up here and label these. We said that X was the bread and Y was the cheese. And so the question, how many loaves of bread can he buy if he doesn't buy any cheese? If he doesn't buy any cheese, then he can buy 8 loaves of bread. So the idea here is that we're able to look at a sentence, come up with a function, an equation, put that equation into a table, and make sense of the graph. Let's try another one. Number 2, Pam is currently $500 in debt, but she's making $100 per day. There's a couple ways we could do this, but let's think about the 2 options. So back at the top again, a per and a starting point, or 2 types, like bread and cheese. Which one do you think matches up with this one? I'm going to say this one is a per and a starting point. So B is your starting point, and M is your per. So she's currently $500 in debt. She's starting negative 500. Let's go ahead and make this equation. Y equals, she's starting at negative 500, but she's making $100 per day. Now you could have, some people might have put that backwards, and that would be okay. Sometimes with word problems, it matches up a little bit better to say it the other way. That's supposed to be 100. So she's $500 in debt, negative 500, but she's making $100 per day. Okay, there's our function. Table of values. This time, we might just do like a 0, 1, 2. Here's the difference. When we have a y equals mx plus b, a slope-intercept form, we're going to do this, 0, 1, 2. But when we have a standard form, we're going to put a 0 here and a 0 here and find the intercepts. We didn't have to. We could have done 0, 1, 2, but this is the way we've been doing it, so that just made sense to stick with that method. All right, if I plug in a 0, I'm going to work this out. So plug in a 0, that's going to give me negative 500. That's where she started at. She started at negative 500. After one day, she's made $100. She was down 500. Now she made 100, so now she's only down 400. Next day, she's up to $200, so now she's only down 300. See, she's making 100 per day. So she starts down here at negative $500, but she's making $100 per day. The next question, how many days until Pam is not in debt? I think we can figure it out, because if she's making $100 a day and she's down $500, then how many days is it going to take her? It's going to take her 5 days. Why? Because 100 times 5 plus negative 500 is equal to 0. So I just used this equation that we had, but I plugged in a 0, or excuse me, plugged in a 5 just to check my answer, and that brought her total up to 0. So now she's breaking even. She's not in debt. Okay, one more problem on this page. The next page is going to be a little bit different, but similar concepts. So mowing lawn pays $12 an hour, while delivering newspapers pays $5 an hour. You make a total of $120. This one's a little bit confusing to me because it uses the word per, but yet then you have this total. So let's look at those 2 choices again. This one says a per and a starting point. This one says 2 types, type A and B add up to a total. So even though these both have a per, they don't have a starting point. So I know that word per can maybe throw you off, but if we have a total, that's going to be standard form. So we're going to use this form. And so it's $12 per hour for mowing lawns and $5 per hour for delivering newspapers, and you make a total of $120. And we talked about how when we're in standard form, the best thing to do is put a 0 here and a 0 here, because we're going to use that cover-up method. So I'm bringing back my big cover-up dot. First of all, I do want to go in, and we probably should do this in the previous one too, but at least for this one, I want to go in and say what was X, what was Y. Mowing lawns was X, and newspapers was Y. And I should put that on my axes as well. So mowing lawns was on the x-axis, and newspapers was on the y-axis. Let's go back just a second to number 2 to make sure we have that there too. And what was X and what was Y? Like, we went through that whole thing without even doing it. But usually time is usually on your x-axis, And by time on this one, we're talking about days. So that's going to be our x is how many days it was. And our y is going to be how much money she has. So this should be money and this should be days. That makes it a little bit, makes more sense to us now, I hope. But back on number 3, I'm going to use my cover-up method. So I'm going to cover up x, and I have to divide by 5. So I'm going to get my calculator out, and I'm going to divide by 5. And I believe that's 24. And then I'm going to do the other one, and that is I'm going to cover up the y and divide by 12, and that's going to give me 10. Okay, so now I have on my graph, lawn is x, newspapers is y. So 0.24 is newspapers, and 10.0 is lawns. And remember we said we were doing a rough sketch, so this doesn't have any increments on it, so I'm just going to make my line here because I really could count by whatever I wanted to count by. And I don't think we need to do a third point on this either. And this doesn't have a follow-up question, but let's think about if you didn't deliver papers and you only did lawns. If you only did mowed lawns and you did not do newspapers and you still made a total of $120, how many lawns did you mow? So that was answered here. 0 newspapers, 10 lawns, that should give me $120 because that's what my equation was. So you really mowed 10 lawns if you did 0 newspapers. All right, let's skip over to the back. At the top, I wrote, just to remind you, slope-intercept is per and the starting point. Standard form is 2 types. That's type A plus type B equals a total. Okay, so we're going to do a similar thing. The problem, though, is that we don't have a situation. So this time we're given the equation. Here's our equation. We have to decide what kind it matches to. Well, this equation looks to me like a standard form, and we have to think of a situation. So we're going to think of some situation where we have 2 types of something that adds up to $12. So maybe, all right, maybe it says $2 for fries, $4 for hamburgers, and you have $12 to spend. So how much food can you buy? We kind of went with junk food, didn't we? Well, that's the way it is. So this was how many fries we can order, and this is how many hamburgers we can order. So if we order 0 fries, we'll figure that out. We'll do the cover-up method. If we order 0 burgers, we'll do the cover-up method. All right, so I brought back my dot so we can do the cover-up method. But maybe before we do that, we should go to our axes. And so our x-axis is the number of fries that we can buy. And the y-axis is the number of burgers that we can buy. All right, so we need to do the cover-up method and find out how many that is. If we cover up the x, we divide by 4, and 12 divided by 4 is 3. And if we cover up the y, we divide by 2, and 12 divided by 2 is 6. So if we don't buy any fries, we can get 3 burgers. If we buy 6 fries, we can get no burgers. And usually we want a combination of some kind, so maybe we should put another point in there somewhere. So just for fun, let's maybe say, what if we want to get 2 fries? Then how many could we get? Well, to figure that out, we want to go back to the original equation and take 2 times 2 plus 4y and set that equal to 12. So that's 4 plus 4y, so I need to subtract 4. So I get 4y equals 8. I divide by 4 and I get 2. Now I know I did that really quickly and you might not have followed along, so we can go over that in class, how to put that in our calculator. Okay, so, but we know that if we have 0 fries and 3 burgers, or we could have, and I'm going to label that point, or we could have 6 fries and 0 burgers. And I'm going to connect those points. And the one we didn't put on there would be 2 and 2. So it's just hard because we don't have graph paper to do that. But basically why we do this is any point along that line, like I said, 2 and 2, Or again, if we had graph paper, we could see what other combinations we could have. But in this case, we're just going to set it up this way. Number 5 is really, really similar to number 4. We just did one very similar. We might do that one in class if we need to. Let's skip down to number 6. Number 6 is a little bit confusing, but let's take a look. We have y equals 25x. Which one of these do you think it matches up better to? Seems to me like it matches up better to this. The problem is there's no b, but you know what? We can always add a 0, and now there's a b. So there we have it. Okay, so this situation, remember that your b is your starting point, and your 25 is the per, how much it's going up, whatever. Well, let's say that you started with $0, but you're making $25 per day working for your dad. Okay, so our table of values on this kind of slope-intercept form, I usually just do a 0, 1, 2. We need to plug them in. On the 0 day, means you haven't actually started working yet, you have $0, because if I plug in a 0 here, 25 times 0 is 0. But the next day, after 1 day, I've made $25. And after 2 days, I've made $50. And I think it'd be good if we went and put our labels here, because once again, x is time, which in this case was days, and y is how much money we have. So our y is our money, and our x is the days. So it starts at 0, 0, and every day we're making $25 per day. Again, it's a rough sketch. We don't have increments. We don't know how big these things are, so we just know it starts here and it's going up. Okay, that is how we look at equations with word problems, with context to them. We'll do our examples like this in class.